Question 1 says an object is moving in a straight line at a constant speed. A force is applied to the object. State the possible changes in the motion of the object. So this question is about Newton's second law, which tells us when there is a resultant force on an object. If initially it was moving in a straight line at a constant speed, that implies the resultant force on it was 0, but now a force has been applied to it, so the resultant force is not 0. There are 3 or 4 things we can say. It could accelerate. Now, accelerate in physics is the word that really describes all of them. By accelerate here, what we mean is it speeds up. Another way it can accelerate, but a separate answer, is to slow down. If you wrote change speed, I think either of those could cover that. And then the second point, or sorry, the third point that we could write down is about it changing direction. So a resultant force can cause something to change the direction it is travelling in. This is only for 2 marks, so any 2 out of these 3 options here should be good for the 2 marks. Part B, figure 1.1 shows a skier taking part in a speed competition. The winner of the competition has the highest average speed over the 100-meter section shown in figure 1.1. The skier starts from rest and has a constant acceleration. He reaches a speed of 60 meters per second in 16 seconds. Calculate the skier's acceleration. So the equation to calculate the acceleration is the change in the speed over the time it takes. So the speed in this case, he starts from rest, which means 0 meters per second, and goes up to 60. So when we're writing this down in physics, we like to say the final speed minus the initial speed, although the initial speed is 0. So of course the top is just 60. The time it takes is 16 seconds. So when we do this calculation, 60 divided by 16, we should write our answer to 2 significant figures. So it's 3.8, and the units of acceleration are meters per second squared. 3.8 meters per second squared. 2. Over the length of the 100-meter section, the recorded time is 1.85 seconds. Calculate the skier's average speed over this section. So the average speed we calculate by taking the total distance over the total time. So rather than looking at individual parts, we're just going to look overall in this section. We don't mind if they speed up or slow down, so it's a 100-meter section and it took 1.85 seconds. So the total distance is 100. The total time is 1.85, which gives us an average speed of 54 meters per second. Suggest why the skier bends his body as shown in figure 1.1. Explain your answer. So in questions like this, with 2 marks, we need to make sure we do both parts of it. There's a part that asks us to suggest, and there's a part that asks us to explain. Now, in terms of why they've done that, I think the most likely answer here is to reduce the air resistance. Instead of air resistance, we could call it the drag, or we could call it the friction acting on the skier. And then why do they want this to be less? Well, if we've got smaller backwards force, it of course means their forwards resultant force will be bigger. So we could say to increase the resultant force. Or we could sort of explain why that's a good thing. So we could say to increase the acceleration. If there's smaller backwards forces, the acceleration should be bigger, and therefore we should say to increase the speed. So what they've done and why they've done it.